So I'm going to talk about a bit technical today. So let me see how should I start? Anyone here write programs? Oh, great. So because I'm going to write program in this session, and it looks like it is the only one in this conference. So anyway, this is me. So I write code and I do some agile coaching and so on. My name is Steven. In case if I forgot to introduce myself. So if you have any questions during this session, please feel free to ask. And in English, in Cantonese, I can pick up questions in Mandarin as well. But yeah, these three languages. And so maybe I should start quickly. I guess for those who write code, you might have some experience like this. I hope I don't have to touch that some part of the code. And especially when your code base is getting old and you don't know what that code is. And once a time I was in Chengdu, I worked in a big telecom company, and they showed me a piece of, well, actually a class that lasts for like 20,000 lines for a class file, and then and they told me they don't know what that is, but people keep working on it, and just copy and paste a little bit, and then well, it's scary. People somehow happen to know a little bit of it, but it seems like okay, copy and then paste and then it works. But the worst thing is that they are actually making it worse, making it more difficult to understand and more difficult to tidy up. So what we are calling this design dead software, meaning software that is getting more and more difficult to maintain. And in a way, some company actually died because of this. You probably heard this kind of story often again and again. The code base is old, it's getting harder and harder to maintain. What about rewriting? Sounds familiar? But if you are lucky, you might survive that. But there are many companies who cannot survive those periods because when you're rewriting it, you have competitors. They are picking up, right? And so I think the most famous case we know of is Netscape. If you are old enough to know what Netscape is, and so they rewrite it and then become Firefox. But during those periods, Internet Explorer pick up, right? So and they lost the market. And now I'm not sure who's leading today, but someone, if someone happened to rewrite again, then they know the lesson. And that is also another interesting observation. So if you happen to use Firefox or Chrome, you notice that their release cycle is pretty short, and from time to time you get update on that. So they are changing their ways of working. So also from my observation, how come code base getting harder and harder to maintain? So one of them is the unrealistic deadline. When your boss push you hard enough, you know how the trick to write back code. And in one occasion, I paired with another programmer. He sat next to me, and then okay, we are pairing, writing some code, and his boss called him. The voice is so loud that I can hear it, and please complete something like that. And then the programmer opened the file, write a comment, says to do, and then write the function just the first line and then the end line and with the comment to do and then commit and then he called the boss, hey, I'm done. So if you push your employee hard enough, then they will do this kind of stuff. And that also relates to the trivializing programming, meaning companies that they don't emphasize those developers skill enough. So end up they systematically produce crappy code. So yeah, so that brings us to the more thinking process about, or the mindset of the of how we think about our work. So if you think, if the thing that if the company is still thinking in terms of economy of scale or wait, okay, and having a big design up front, these kind of thinking will always lead to bad code, and by adopting changes and understanding that change will happen and how the question is how we cater it, then we have some better chance surviving. So as the beginning of this session, so I want to share with you that in order to be shippable, to be ready, we need some different way of writing programs. And right, so when it comes to, when people talk about agility, most of us focus on the organization agility. And well, actually, it's quite obvious when you go to conferences like this, and most of the talks are about organization. But at some point, you will be limited by the technical agility with your developers. Let me see. So this session, I will share with go over some of these topics. Continuous integration, specification, by example, test-driven development in particular. Good. Okay. Then, the first one is continuous integration. So, the text here is actually quite obvious. So when I ask what do you practice continuous integration in your organization, most companies said yes. Oh, by the way, if any of you already practice continuous integration, and let me see, and who else have used any continuous integration systems like Jenkins, CI, and so on? Okay, some hands. And so the first thing I want to share is that this is 2016, and if you haven't used any continuous integration system, please use it. Most of them are open source, some of them are cloud-based, and so the cost of using it is so low that there's no reason why you don't use any of these continuous integration systems. But the focus here is not about having one of these systems. Like what is written here, and or I would even put it more straightforward. Continuous integration means integrates continuously. So it's very straightforward. But having just a system to running builds and tests are not enough. So it's a developer practice to keep a working system, and by integrate continuously. And by integrate continuously, it means once you check in code and then you frequently check in code and then the system will of course do the build and so on, and everyone practice that. So in a good day you can commit many times a day, and if you have a group of people working together and everyone does that, and let's say, so you can have the number of commits is very high, but at the same time it's also safe for you to commit in a small chunk, because if you work with a larger group of people, well, the typical story is that how do we handle like merge conflict and so on. But if you are only committing in a very small chunk, if bad things happen, it's only a few lines. So it's easy to revert back, and also easy to identify what went wrong. It's only a few lines. If you commit like several hundred lines of code, you will find it very painful to revert. So it's a good idea to commit in small changes. So for those who are not using any CI system yet, this is how it works. So when a developer checks into the source code repository, and then we have a continuous integration server running and listen to these commits, and whenever someone commits, and it will pull out the code and then run compilation, and then if the build succeed and move on to more testers, and in some companies they even deploy the commits. So so I also want to make a distinction here again, having a CI system and practicing continuous integration. So this is about having a CI system, but continuous integration is about the practice of integrate frequently, continuously. Okay, I think I will share this slide later on, and you can read it. So again, this is 2016. I hope that every development team are able to build their whatever they are building, package and so on, with a single command. And yeah, it's kind of scary sometimes when actually early this year, I pair with another team of people, and then I asked, hey, do you know how to build? What kind of tools do you use to build? And well, it's obviously Java code base. The guy told me that it's Eclipse, and I thought, oh, you don't really know what you are building. And until I dig out and find the Maven file. Oh, okay, that's Maven. So I'm not sure if that is a similar situation in your company, but in some company, the tendency seems to be only a few people know exactly how the build process happen. You better share this knowledge with the entire company. Deployment is even further away. If you can do it, that will be even better. So when we have a continuous integration system, we can run build frequently, and it would be even better if we can have tests, right? So these are just the machines, and they can do the job. So running builds and don't waste their CPU time. So run automated tests. And these are the typical test pyramid you can think of. Unit tests here, they are running very fast, and they are relatively easy to write. And depending on how complex your product is, you might have some tests at component level and integration level. And most products have some system tests and testing end to end. And this is another portion that you might want to know when you are thinking in terms of different kind of tests that you want to have in place. So on the let me see on the y-axis is over the top is more business facing tests, testing about more about the product, but on the direction down here it's more about the technology. So technical support your technical technology development, and over that side also support the team, and over this side is also about the product. So different kind of tests that you might want to consider to have. And any of you have any automated tests in your company? Oh, it tends to be the same set of hands.
I had a question.
Yes.
So this is all done once, right? I mean, it's not an order in terms of how the tests are written, is there? Is there an order in, when the tests are created?
Order of the tests.
Yeah. Like when is it created? Yeah, you create it.
Oops.
Because obviously there's business facing and technology facing.
Yeah, it's
What's the best
if
way?
you don't have any automated tests in place, the first question I would ask is what kind of problem that you have. And when you suffer enough amount of pain, then you will have enough buy-in from your company to do some of these tests. So if the pain happens to be in terms of
Well, it's not a question about whether the tests are important, but what's the best way to come, like inside program, I only worry about the unit tests. And so, but I sometimes do the functional test, but when does that come into play? How do you work with the business side and the technology side to come up with these tests? You know? Not so much about the writing test. I agree with that. Sure.
Overcome the difficulty of writing tests. Is that what you're asking?
No, but just I guess best practices of interacting with business
Right.
side and how best to come up with these tests with stuff.
Okay.
Maybe it's we could just.
Okay, I will cover one of the technique later on. Specification
Okay.
example.
Sure.
Oh yes, actually right here. So yes, specification by example, and it goes with different names. So in this session, I try not to confuse you by different names. You might find it on the internet: behavior-driven development, specification by example, and also acceptance test-driven development. And so application workshop, or if you practice Scrum, there is a meeting called product battle refinement. And the first important thing about this workshop is to have such a large area, people can talk to each other, and invite the right people. So people who know your product, people who implement your product, and people who test the product, and so on, and different skill set and people knowing the business, and other stakeholders are also invited in this meeting. So when you ask what is the best time to write system level or functional tests, this will be the best time, in my opinion, to start with. So anyway, you have to understand then the needs of your customer before you do the design and write code and so on. So this is a very good workshop you can start with. And the key idea here, other than the setup and the people, is to use examples, concrete examples. The most concrete examples you can make it a table like this, and what's the input? Imagine the input from A, B, and C is like this. What should be the score? And so by making this very clear, it helps us understand what customer needs and what we need to build. And also one interesting trick about using example, if you are the product owner or the stakeholder, you can actually ask the team, if the input from A is this, B and this and C and C, what is the score? Well, check whether they know the answer. And if you have a large group of people, firstly, get a bigger room. Secondly, you can divide them into different groups. Smaller groups, they use different corners, and like a group of 4 people is a good size. If you have more than 5 people, some people tend to go quiet, and or the discussion will go forever. Both of them are not very good. And let me see. Oh, right. If you can. So they are trying to write examples over here. I guess you might not be able to read it. Well, the purpose is actually it's meant for people not to read it, and it's some kind of information. So, and they are trying to even draw some wireframe about the UI. So also about understanding what they're going to build. So by starting with examples, one thing that is very interesting is that example, on one hand, elaborate requirements. So we understand what the requirements are, and at the same time, examples can become our tests. So this is a very key idea in terms of writing tests, because for those who have some experience writing automated tests, you know how they feel about writing tests. Boring. And most people will tell me, oh, it's boring, we spend extra time writing automated tests. But now the situation changes we are not writing tests after the code is built. We are actually writing examples during the understanding of the requirement. So essentially, you are writing a requirement document and test plan at the same time. So these examples can become tests, and of course, the tests verify that whether our program performs what people ask for. And in order to have maintainable tests, we pay attention to these different kind of things in the examples. Some of them are more related to the business rule, so we try to highlight these business rules. And some of them are more technical activities. So how should I elaborate that? So imagine that you are writing a test for ATM machine. The business rule is for saving account is rather simple. So I have 1,000 Hong Kong dollars. If I want to withdraw 1,500 Hong Kong dollars, it should say, hey, you don't have enough money. Right? That's business rule for saving account. But if you focus on technical activities, I should say it like this. If you read a test, then that focus on technical activities, what you will find is that, okay, I go to the ATM machine, and then I put my card inside, and then I type my password, and there is a menu, and I click on the withdraw money button, and then I key in 1,500 and press enter, and the system will show me the error message. So So the difference, you may hear the difference already. It's very verbose and detailed steps. So these detailed steps are what we call the technical activities. Similarly, you can imagine you are testing a web-based application. So if the test consists of these tiny little steps like open browser, highlight a certain DOM element on the web page, key in something, and then press enter, and so on and so on. It tends to be very verbose and also hard to maintain. I also visit, so happen it's the same company in Chengdu, the big one, and I happened to visit the test automation team, and the people told me that they have no idea about the test script. It's even worse than not having it. So if your test script is full of these tiny details here, it would be hard to read the business rule that you actually want to focus on. So I noticed that I have been talking too much. And so I want to show you, wow, really small. Oops. No. Let me see how I can get bigger fonts. Can I find the font?
I think it was in text style.
Huh?
Text. The first one.
Oh, text. Oh, yes. Yes. Wait, is that the largest one or the no? So let's see what happens. See? Is that larger?
Oh.
Maybe it should be more. It should be larger than that.
I think it's not this setting.
Hmm?
It didn't react.
Oh, okay. Well, anyway, I can do another thing.
How about Command Shift equal?
I'm going to use VI. How will it read better? Okay. So this is the kind of specification that.
Steven, you just need to do like upper press. That's a shortcut.
Oh, what is the shortcut again? What is
Command
that?
plus.
Command 1?
Yeah. Command press.
Oh, no. Command press. Command what?
Plus.
Plus. There you go. Thank you. So anyway, let's take a look at one of these files. Wait. I should put this one. Okay. So with a text file like this, you have a bunch of example username and valid and invalid username and password combinations. You can put it like a table like this. And so as you see, invalid with invalid username, valid password, valid username, invalid password, and so on and so forth. And we can run tests like here. Let me see. So you just see a browser pops up, and then and then it flashes very fast. So what it does is actually running through these tests, and then it can immediately tell you about the result. So it's actually a web page I'm running on my local machine, so that's why the test runs very fast. And in some occasion, I know it will run somehow longer time, but better have some tests like this. And this text file is quite readable. So for at least you can put the tables that you have during the discussion like this onto this kind of text file, and then it lowers the difference between what people discuss during the workshop and also the stuff here in this file. So there are others. Oh no, this one is more interesting. So another way of writing this kind of text is over here. So given browser is open to login page, when a user demo logs in with password mode, then welcome page should be open. So it's more like English and closer towards what your stakeholders can understand. So by having, so at the same time it's a specification of the system and also running tests that will show you the result whether it pass or fail. So we minimize the gap between requirement and tests. So these are these tools are open source software. So the one that I just demonstrated is called Robot Framework, www.robotframework.org. Another popular one is Cucumber, and Fitness is the oldest one. Oh, I wrote those names over there. So these are the common ones and also open source, so free to use. I think we have a question earlier. Does that answer the question earlier?
Yeah, and these are more like acceptance tests, right?
Yes, yeah, for acceptance tests. So try to start that from the moment you try to understand the requirement, and get those examples ready. Then writing those tests will be a lot easier.
Which do you prefer of the Cucumber is pretty popular? Do you prefer robot because you're using robot?
It depends. So depends on what kind of product you are building. So for web-based, I don't see much difference between robot and Cucumber. But if you are testing embedded equipments or equipments in general, so I happen to have some customer building telecom base stations, those big machines in the mountain. So they use Robot Framework. For those kind of equipment, Robot Framework tends to support better. If you are working with mobile phone applications and so on, Cucumber has a pretty good support on that.
What language dependence?
Good point. So yes, that's the unfortunate developers' war on languages. So Cucumber is written in Ruby. If you are familiar with the Ruby world, Cucumber is perhaps the more comfortable choice. Robot is written in, you already guessed the answer, right? Python. So the test itself, most of the time you're writing text file actually. So it shouldn't matter so much about the language. But it is also a difference here. So with robot, you tend to write less code. So there are occasions that you might still need to write some Python code. But most of the time you should be writing text file. For Cucumber, the steps, the detailed steps are mostly written in Ruby or well, other kind of Ruby implementation.
What about fitness?
Fitness is Java based.
Yeah. How do you see that fitting, or the strengths of fitness over delegates?
As I don't mention too much, that means I mostly find robot and cucumber fit in most scenarios. It's the oldest one, and again, the thing I look at is how well these two support the product, the interface of your product. Web-based mobile phones, that tends to be standard, but for equipment, it tends to vary, and chances are you need to write up your own interface libraries. So far, I still find robot easier to do that, and yeah. Otherwise, Cucumber is quite friendly to use. This is the most exciting part about writing writing code live. Things happens. Okay, there. Okay, so so prime factor exercise refers to the small function or utility that when you provide an integer like 4 is so 4 is a factor of 2. 2 times 2 equals to 4. So if you put 4, then it should give you 2 and 2. If you give 24, then it will be 2 and 2 and 3, right? And 2. Yeah, something like that. So that's the prime factor exercise. So one is a special case. Well, not null, sorry. No one should return null line these days, but empty. So the first thing here, I'm not writing code, I'm writing classes. An empty list in Java looks like this. And now I need to think about the class I'm writing now. And I make it a static method. And so let me see. So it's complaining. And then your
not complaining, just a reminder.
Okay. Okay, sure.
And
Thanks.
the book is.
Oh, right. Books. So I will make this demonstration really short. But for most modern IDE for static languages, it is smart enough to tell you what's wrong with your code, and most of the time they are correct. So I'll just ask what's wrong, and then follow what I says. And it still complains. So create a method here, and by writing failing test, I need to do something. Let me see. At least it has to compile before knowing that is a failing test. Oops, no. Okay, so it's a failing test. I think one of the most important things that when you write unit tests is the speed. It got to be very fast because you will write many of them and you want to run them all the time, run them on your local machine. So it got to be very fast. If it is slow, then you have no motivation moving forward. So I have a failing test, and the fastest way I can make it pass is like this. So notice that this is the second step in test-driven development, and I'm just the only goal is to make it pass by doing the simplest thing possible. Good. Okay, pass. And with when it's passed, then now I can write more tests. And I think I will stop when I have a second test pass. So if I put 2 here, it shouldn't be an empty list anymore. So it should be a list that contains one factor called 2. And we can run the test again, and if else, so is the time I can write code. So what should I write? Now I can, there are 2 tests I need to pass, and I am doing it quick. No. Doing it quick is actually the worst way I can make it fast. I should do it step by step. In that case, and factors of 2. So I introduce a if statement here to make the test pass. Somewhere on here. Okay, I'm not complaining anymore. And I make the test pass. And I can add more tests and then add more functionality, and gradually this piece of code will get longer. But we have tests, knowing that I'm not breaking things up, so I can have the confidence to clean up the code if this gets really messy. So it's also an important practice to refactor your code, and you should have no excuse when you have great tests like this, and it's passed, and it's so you have the when I think it's a very similar story among developers. There's a 1,000-line long function. You always want to improve it, but no one dares to do so because we don't have tests. And by having these tests, then we now have the confidence to fight against those monster methods. Okay. So let me see, and so these are the details for writing unit tests and so on. But I tend to skip now. Yeah. So for good unit tests, it's going to be fast. Each of these tests should be isolated. It's repeatable, and it's self-explaining. It's very clear that it's either pass or fail. There is no such thing as failing but okay. There is no such thing like that. Timely write the test at the right time. So try to keep your test with each of these tests only with one assertion. So one test tests one thing. So you know that when one test fails, you know exactly what breaks that. Again, it should be very fast because if you practice this well, you will have a whole bunch of these tests running around. So I should be closing this session soon, and on moving forward to these practices. Well, having a continuous integration system is easy, but it takes a lot of practice to do so. And if you also practice test-driven development, it makes you easier to commit in smaller builds, because with with tests like that, you can always commit code when the green is when the result is green, right? So you have the confidence commit small code and commit frequently. And for specification example, having a workshop like most companies are not very used to having a workshop like this. You may want to hire some external facilitators or coaches to bring in your company to run those kind of workshops, and also allow some budget, allow some time in terms of planning when you are writing these tests and so on. Again, it goes back to the reason why why people write awful code, because of unrealistic deadlines. And having a pair programming session, and it will be very useful to spread out this knowledge of writing tests and so on. And if you have a meeting room like this, then better have a table and then a projector connected, and then someone write code, and then someone can take turn and to write tests and so on. It's more fun having a group of people writing code together with a big screen, and people can learn from each other. So practice, practice, and practice. Prime factor is a kind of small exercise that we call coding kata. So if you search the word coding kata, K-A-T-A, you will find many different exercises that you can try out, like prime factors, tennis game, and so on. So yes, there are more books that you can read, and this website have a good summary about what I'm saying. And let me see. If you want to start with one of these, my favorite is working effectively with legacy code, because almost all companies have legacy code. And by legacy code, the definition here is the code without tests. So you can make legacy code fresh, and don't do that. And specification, by example, is a great book about understanding. It's more about understanding and collaboration than writing tests. Writing tests just became a side product of that. This is a very brilliant idea. And Clean Code is another one book that I wish every programmer have read. It's really good in terms of what is readable code. And refactoring is also a nice one about how to tidy up the code. So with that, do you have any further questions? So is it readable? Okay. So oops. Wait. So I think I have a book in the back. I need to give it out to someone. I choose you because you asked the first question.
Thank you.
It's it's really difficult to be the first one.
What's the book?
Oh yeah, what's the book?
What's the book called? The Phoenix Project.
Yeah, this one is good. It's a really good book.
Yeah, the organizer forgot to buy any books that relates to coding,
Really?
and the closest one that I can choose among those is this one. So yeah, hope you enjoy this book, and I will be here around the entire day. So if you have any questions, please feel free to ask me. So thank you very much.
Thank you.